In this video, I'm doing removed nth node from end of a list. So given the head of a linked list, remove the nth node from the end of the list and return its head. Okay, so question is pretty simple. If I'm given a linked list and then a number, I need to return the element that is n away from the end of the list. So 2 away from the end would be 4. 1 away from the end would be 2, so I'm removing this one. Okay, so I think that first what I want to do is I want to get the length of the list, and then if I get the length of the list, I know which element. If I get the length of the list, I'll know what element that I need to remove, because that'll just be the length of the list minus n. For example, in this case, length of the list is 5, and then n is 2. So 5 minus 2 would be 3. So 0, 1, 2, 3, which would be this one right here. And again, here length of the list is 2, n is 1. So 2 minus 1 would be 1, which is 0, 1, which is just this one here. Okay, so first of all, I'm just going to get the length of the list. So I want to keep head pointing at the start. So we'll iterate and we'll make a new list node. So list node x equals head. Okay, int length equals 0. I guess we'll just do. Let me just look at the constraints for a second. Okay, so there's at least one node in the list, so int length equals 1, and we'll do, let's see, 0 actually, we'll do, okay, so while x.next does not equal null, while x does not equal null, length plus plus, x equals x.next. Yeah, and that should give us the length. Then we can do int target equals length minus n. Now we have our target, so now we just need to get to the node which you want to remove, basically. So we're gonna need, we're also gonna need the previous node. Okay, so I think we're gonna want to get to I think we're going to actually want to iterate until we get to the node before rather than this node itself, because then we can make this node's next node this node's next node, so 3 would just become 5, which would just remove 4 entirely from the linked list. But first I wanted to have an edge case, because otherwise there's not going to be a previous node if the length is just 1. So if length equals 1, return null. Okay, n this here tells us that n is always going to be a node inside the list. It's not going to be an element that is bigger than the list itself, so we don't have to worry about that. But okay, int target equals one, int prev equals target minus 1. Okay, so now I want to get to the node, and we can do that by we'll make the tree node itself. Sorry, list node remove equals head for int I equals 0. I is smaller than prev dot length. Sorry, just prev plus plus. Remove equals remove dot next. Okay, so what this is going to do is this is going to place this at the element. So remove is now going to be the element right before the element we want to eliminate. And then we'll just do remove dot next equals remove dot next. And I think this should work out for us. And then we can just return return head. And I think that this makes sense, but let me just walk through it. So I am initializing this node x at head, and then this loop here is basically giving me the length of this entire list node, stored in this variable length. If length equals 1, I am returning null because the only element to remove is just this one element here. Otherwise, I'm setting target as length minus n, which then represents the element that we want to remove. And then I'm setting prev as target minus prev at target as target minus 1, which is the element before the element we want to remove. And then I'm simply setting this element's next to this element's next. So if this is null, this will just be null. Otherwise, this will be pointing to whatever this is pointing to. And then I'm returning head, which is still looking at the start of this whole node. So let me give it a run. Okay, let me submit it. Okay, looks like we are getting an error here. We passed most cases, but with this one there seems to be a problem. So let me look into this one here. So we want to remove okay, we want to remove length is 2 times 2. So target in this case length would be 2. Target would be target would be 0 because the length minus n, so 0, and then previous would actually be -1. So what's happening is I'm not actually entering this loop at all. And so remove.next, so remove is currently set to this one here, I guess, and then remove.next is equal to just null, which is why 2 is getting removed. Okay, so we'll do okay, so if we're okay, so I guess we need an exception for if previous isn't below target, then that means that okay, I guess if target equals 0, then that means, which is the most it'll ever be, target will at most be 0, then that means that the element we want to remove is right at the start. So I guess there is no previous in that case. So what we would want to do is okay, so let me just do, okay, we'll do if target equals 0, then in that case and remove is still at head, so then we can do remove.next equals null. But we want to return this one, so maybe remove equals remove.next. Okay, we'll do list node temp equals remove. Remove equals remove.next, and then we'll do temp.next equals null, and I think this should remove the previous one. And then if that's the case, we can just return head. Actually, I don't need to try this, but let me try running here. Okay. Let me think here for a second. Target equals 0. Okay, looks like I'm not accounting for some certain cases. Okay. Target equal length minus n. Previous equals target minus 1. So what I need to do in this case is I need to simply just return but I'm not too sure. Okay, what if I do if target equals 0, can I not just return head.next? Okay, and there we go. So what I was doing here is essentially just accounting for the cases where the node to be removed is at the beginning. I guess I don't need to remove this node's pointer to the next node, but I can just have head be starting here and then it's removed. So there we go.